Our next panel is one that is near and dear to my heart, which is the Federal Agency Panel, discussing emerging trends in sustainability within the federal agencies and organizations. It is moderated by no other than Helena Wisniewski, who is certainly one of our NAI members traveling from perhaps the furthest away to get to Washington, D.C. Helena is a fellow of the National Academy of Inventors and professor of entrepreneurship management, marketing, logistics, and business analytics at none other than the University of Alaska, Anchorage. So please help me in welcoming Helena to the stage.
Thank you very much. All right. Well, welcome and good morning, and welcome to the Federal Agency Panel on Innovation. And it gives me great pleasure to introduce our distinguished panel members. Their bios are available in the program, and I'm just going to give a brief statement about each for this morning. We have Dr. Tony Tether, who is the former director of DARPA. And if you remember, he was the one who did the DARPA Grand Challenge, the turbocharged autonomous vehicle production in the US, and he served in a lot of executive positions. I know him since I served at DARPA, and that's where we met. Tanya, she's the regional director of the National Security Information Network, which is a relatively new agency, and so we're proud to have her. A lot of innovation going on there. Dr. Sunita Satyapal, she's director of the Hydrogen and Fuel Technologies Office in Department of Energy, which is over $1 billion program. So, and she has a lot of exciting things to share. Kanuck, who's Chief Executive Officer of EXEDEC, and he served as the first National Intelligence Officer for cybersecurity. So you have a wealth of great intelligence and experience to bear. I'd just like to set the stage for what the panel is about. The panel is really focusing on emerging trends and sustainability within federal agencies and organizations. So emerging trends are driven by emerging technologies. And center stage is AI, topic near and dear to my heart. And so AI, as you know, is transforming our lives and will continue to do so. We can't even imagine the ways it will. But the real power comes when it's merged with other technologies, such as digital twins, Internet of Things, robotics, quantum computing, and other emerging technologies. So this really brings us to the first question. Which emerging technologies do federal agencies consider most important, and how are they preparing to leverage these technologies? So, Dr. Tether, would you like to start?
Sure, thank you very much. I'm here to talk about digital twins. And that's an interesting concept. They pose it as brand new, but it's not, and I'll get into that. But as a definition, a digital twin is a virtual representation of an object or system that spans its life cycle, is updated from real-time data, and uses machine learning and so forth and so on. In plain English, what this says is that it's a highly complex virtual model that is the exact counterpart, a twin, of the physical thing. Okay. The thing could be a car, a building, a bridge, and so forth and so forth. What this means is that a digital twin is a vital tool to help engineers and operators understand not only how projects are performing, but how they will perform in the future, analysis of the data from the connected sensors and so forth and so on. Now, really, this is not a new concept. I'm an old guy, and roughly 50 years ago, we started a company in 1970 doing the allocation of research to a system. It was basically, we need to know the system. We had to have a performance function, and in real time, this was the first time, because computers were just becoming available. Some of you don't probably remember that, but they were just becoming available, where we could actually look at a system, see something, and if it was going wrong, we could in real time correct the system and change the system. The company got started because of the New York blackout, which ran across the northern part of the country. And what was found out was that that blackout really didn't need to occur, but the facts were that the system did not know how to stop it from going. And so we got involved with real-time resource allocation and control. And this really is a digital twin, was what we were doing back then. Now, of course, the computers today have really gotten to be much more sophisticated and capable than what we were dealing with at that time. But basically, we would take a process and we would create a model of it, and in real time, we would calculate the optimal control. And that optimal control, unfortunately, because of what we were communicating, wasn't really good for very long, so we had to keep updating it as we got more and more information. As time has gone on, we've gotten very good at coming up with a model of what the process really is, and that means that now you can do a allocation or optimal allocation of resources, which will last for a little bit longer time, and so you're not constantly having to be doing it over and over again. But a digital twin is really a very vital tool. It helps engineers, operators understand what's going on, and it also means that a system, if something goes wrong with it, the control system will automatically know that something has happened and will change the model in order to have the new model and put that back under control. A very, very vital thing, and I hope all of you take the time to really learn more about it, because it really is the future and is really available today, because the computers we were using back then were, well, they were not very fast. And today's computers are thousands of times faster, so you can do things today that you could never do back when we were first doing this.
And what's really interesting is that, I don't know if you realize it, but in the future, everything will have a digital twin, whether it be a human, a city, corporations, assets. So something to really look forward to in the future. So moving from digital twins, Sunita, would you like to talk about what you're doing in hydrogen?
Sure, so thank you for the invitation and really for organizing this important event. And I think after 2.5 decades in both government and industry, this is really the time for hydrogen. We have, thanks to the bipartisan infrastructure law, we now have 9.5 billion specifically in hydrogen, so and we cover at DOE, we fund going from basic research all the way to deployment, and we're really starting to see scale. But the one thing, everyone's heard about the moonshot from, over half a century ago, but how many people have heard of the Energy Earthshots initiative? Okay, a few, but not that many. But again, I think, and why this is so important is it's such cutting edge technology. It's moving so quickly. And over 2 years ago, when President Biden asked our Secretary of Energy, what more can we do to really accelerate progress towards meeting our climate goals? Because remember, the administration has net zero by 2050, very ambitious interim goals, clean grid by 2035. So going from 40% today to 100% in 12 years. Again, so much is happening. But that was the beginning of the Energy Earthshot initiative. And the hydrogen shot, which was the first in a series of Earthshots, has this really bold, easily articulated goal of 111 to basically, it means $1 for 1 kilogram of clean hydrogen in 1 decade. And so hydrogen is often called the Swiss Army knife of clean energy. So because of its versatility, you can make it from diverse domestic resources, just split water, for example, and then you can use it in many applications. And so again, it's been around for a long time, but if you ask why so much interest, countries are beginning to see that they can't meet their climate goals without that carbon-free molecule. You can't only depend on electrification. So as a fuel, as a feedstock, resiliency used in a fuel cell, power generation, heavy-duty transportation, making, for example, steel, ammonia. So a lot of touch points with hydrogen. And then the last thing I'll mention in terms of innovation, we have just from our funding alone in my office over 1,300 patents. So issued US patents from universities, labs, industry. We see 30 commercial technologies, maybe another 65 that we think could be commercial. And I think several of you that I see also here were awarded some of those patents. So again, really exciting time, and thanks for organizing this.
So Tanya, you're with a relatively new agency that's positioning itself to be very innovative, so would you like to pick it up?
Sure, yes. So I would like to touch on that. We are looking at emerging technologies like at the ground level. So we're working with academic students and stuff, capturing some of these problems related to digital twins, finding really good energy sources, finding biotech, different ways and approaches to solve problems in interesting and commercializable ways and dual use technologies and stuff. And we really plug into things like the CHIPS Act, which will enable a lot of these technologies and make sure that we can sustainably carry these through in the oncoming decades. And starting early is very important, and making sure that we reach out early and catching that before it's even commercialized.
Excellent. So Sean, you bring a little different perspective from the intelligence community. So if you could share your thoughts, and then I'm going to have you lead the next question.
Certainly, and first of all, thank you very much for inviting me to be a part of this event and this panel. Coming from the cyber analysis and national security perspective where I served in federal government, the one place I'd like to clearly mention in regard to this question is the Internet of Things, which I'm sure you've all heard of, but when I look at the developments that are coming in sensors and industrial control systems and how those are going to be integrated throughout next generation buildings and smart cities and smart transportation networks, whether we're talking about high-speed rail or the future of highways with electrical vehicles and charging. It's going to be a very interactive bi-directional communication flow between assets and their environment, and how that is managed, protected, and maximized for the greatest efficiencies, I think is going to be huge. So I would just underscore Internet of Things in relation of here based on my background.
Oh, absolutely. When I mentioned how important the convergence of the emerging technologies are, so when we're talking about digital twins, Internet of Things is huge in that, connecting the sensors from various assets into the digital twin. And this is a good segue to the next question, and that is, what are the risks associated? We're talking about emerging technologies, and it's a very exciting topic, but what are some risks that the federal government will be facing, and how are they evaluating those risks?
Yeah, and this is a huge challenge. That's no news to any of you, but it's something we used to analyze very carefully on emerging technologies and coming up with the right framework to think about assessing new technologies as you integrate them into agencies and organizations. And I think the benefits are often extremely clear. At the quantitative side, the scale, the speed, the scope with which we can now process massive amounts of data with the benefit of machine learning and AI to identify new opportunities for efficiencies or increasing returns to scale are quite prevalent, and we're seeing those advantages happen every day. There are also some other really qualitative changes that are upon us, whether it's in emerging activities in outer space, quantum mechanics, or synthetic biology, and what we're doing with our own genetics, actually on the cusp of changing the human organism in ways for the first time since we literally got the command to fire and changed our gastrointestinal system, ended up getting blood types. We're really on a cusp of human history here. And so I think a lot of the advantages are quite evident. If I put on my security hat and try to look at what are the potential concerns we have to work at mitigating, the first, if I was in a federal government or agency or organization, I'd be trying to make sure we had the expertise on board to know what we were buying. Okay, we're at a unique period where we're not back in the Manhattan Project or the moonshot. We have a lot of the cutting edge activities happening outside of government per se, often in contractor relationships. But how can those public servants who are tasked with pursuing the societal good and the public good make sure they know what they're buying? Take AI, for example. What are the inherent biases of the culture or the employees that coded it? What is the black box algorithm producing? What are the potential negative outputs? How do we make sure we have the right amount of information to make those choices? And if you look back at other historical technology choices, sometimes when you put them into the infrastructure, and if you're in lean times of economic prosperity or recession, you may not have the ability to go back and reconstruct things. We see that happening with the internet. Folks asking, do we have the ability to go back and create a secure internet or a secure enclave in the internet for those things we want to do with strong authentication versus where we want to have anonymous political speech under our Constitution? So getting the answer right so that you don't have to, 10 years from now, want to be pulling out all the fiber optics again or doing whatever. That's by analogy. Secondly, I come from a national security perspective, so I come from a national security perspective, so I'm very concerned about supply chain risk and foreign intervention in U.S. infrastructure or that of our allies. So not only do you need to know what you're buying from the private sector, you need to know what you're outsourcing and buying globally, because there are a lot of entities out there, adversaries, non-state actors who may have anarchic or terrorist objectives, who will seek to get emplaced in your infrastructure to later have leverage. A third category of concern I would have is making sure the technologies we're emplacing are consistent with our other societal or constitutional values. We've all heard a lot of the discussions of privacy and data. Well, AI takes that to a whole nother level than we had it with, HIPAA data or personally identifiable information in cyber. As something is able to model you, a generative AI be able to model you and predict how you would write an essay or how you would give a speech, who owns that? Who owns the likeness of my thought process? We know who owns the likeness of the image of a celebrity or a non-celebrity. That's a settled matter of law. Who owns the likeness of how you think or how you use the language that you write and speak in? That's interesting concepts that we have to think about. And then the last thing I would say on some of the concerns is we tend to look at the advantages, and I think that's the right place to start. And we look at the ability of these new technologies to help defend us and our values. What you hear less about is that the offense is developing every bit as fast as the defense. We think about AI helping cybersecurity. Well, AI is also helping generate cyber exploits. And we can look down each element here of where these great advantages are coming. There are unfortunately adversaries and miscreants who are very nimble with the technologies as well and are trying to find ways to compromise others, to steal money from them, or to hold them at risk in a coercive event in international politics. So I would advise anyone in a federal agency or organization, as you think about emplacing these new technologies, to also look at their impact on your threat surface area, because you do know that the bad guys and bad ladies and bad folks are trying to leverage these qualitative and quantitative advantages every bit as much as the good folks.
Well, thank you very much. That was very comprehensive. I'll have to have you speak, or I created UAA's first AI course and teach it. I have to have you come and
I'd be honored.
share some of your thoughts. That was really terrific. But the cybersecurity issues and privacy are important because the digital twins are moving towards personalized medicine. So having a digital twin of your human body out there. And then you mentioned some of the other things, like, you know that Singapore is the largest digital twin in the world? Just a little cocktail fact there I can share. But moving on from there, does anybody have any comments as to what Sean said? So, Tanya, I see you nodding vigorously. Would you like to follow up?
Yeah, sure. So thank you, Helena. One of the things that we also try to look at is making sure that people understand their IP protection and how to keep that secure, and looking at where adversarial capital is coming from. So those are things that you need to look at, especially if you want to develop technologies that can be used for dual use. So we, through the National Security Innovation Network, have fostered a few discussions with leaders as far as that relates to adversarial capital, inviting the FBI to present to new entrepreneurs out there and stuff. So those are some opportunities that any innovator should be keeping their eyes open to.
So Tony, since you've served in the Department of Defense at DARPA and been executive at in an industry, what can you follow up to Sean and some of his risk assessments?
No, I really don't. I really think this is a good conference, and I think the subjects have been really good. But I really don't have anything to add.
Okay, so Sunita?
Sure, I think I definitely agree with everything. Maybe one thing, so from the hydrogen perspective, very similar challenges. We have to get to scale. We have to get costs down. Again, the hydrogen shot, it's like an 80% reduction because that will unlock the market potential. The supply chain, huge issues there, just depending on critical materials. Maybe the one other thing I'll add to Sean is also ensuring that we don't have stranded assets. So for example, we're focusing so much on the hydrogen production or let's say electrolysis and so forth, and we need to have that offtake, and that's really critical. So we don't kind of build up the infrastructure and then we don't have the demand, and that's why we've launched in case you haven't seen it, just cutting edge, hot off the press, the National Clean Hydrogen Strategy and Roadmap, which was required by Congress, and so the White House just released that. So now we have the national strategy, kind of the strategy and the tactical plan. How do we address those risks?
Now you mentioned supply chain. I'm writing a book under contract on global supply chain with emerging technologies. And so really looking at things historically to the present time, as well as the emerging technology. And supply chain really is something of great concern, and a lot of controversial and interesting issues coming up there. So this brings us to the next question, and it's related to what you've been discussing now, but what are your thoughts on innovation and sustainability? So Tanya, I have you down for getting the conversation going, so would you like to start?
Sure, certainly, thank you. Yeah, so being able to sustain innovation means really building up those networks and stuff. I really believe in making sure that we can get those problems to the right people and finding the places to get that plugged in. So working with academia, working with industry, early stage to commercialized level of availability and stuff, and really making sure that we can sustain those connections and build up that diversity that we've also kind of talked about here, which it really is important to make sure that we are looking at problems from different perspectives so that we can find sustainable solutions for the long term. And looking from the really cool quantum technology and how we're going to be able to sustain that by really considering also supply chain issues, like how are we going to get those rare earth elements that are needed for the quantum computers, for those microchips. So those are some other key areas that I think are very interesting that we all need to consider.
So what kind of things are put in place to actually solutions to incentivize sustainability?
So there's things like the CHIPS Act that we will leverage, but we also trying to building those networks like I had mentioned before, and then really considering when we go out through the world, I go out there and I look for different technologies that look at different approaches for solving problems. For instance, maybe a biotech firm that can extract rare earth elements without causing acidification, so that we can sustainably get some of those core requirements out of the soil and out of the things that we already have generated. So those are some of the things. Is that the right direction kind of there?
Sure. And Sunita, you said you brought something to share with the audience, a visual.
Yes.
Always like to have something that people can see, right? So, and along the lines of sustainability.
Sure, and maybe I should ask first, how many people have actually seen a fuel cell or electrolyzer? Oh, not too many, so I carry this everywhere with me because not that many people know hydrogen fuel cells, but basically, so if you step, let's say on the gas pedal for, let's say it's in a vehicle. So hydrogen flows on one side and then air, oxygen on the other side. And so again, it's an electrochemical reaction. So you just produce water. And you have catalyst on either side, a membrane. So there are different types of fuel cells, but in this type, protons go through, combine with oxygen and produce water. So it's just much more efficient. So that you don't have pistons, you don't have combustion, you don't waste a lot of energy as heat. So again, it's much more efficient. They're modular, scalable. You can, for instance, in a vehicle, they're commercial vehicles now, over 16,000 in California. Toyota, Hyundai, the stack is about this large, so it replaces the engine. They can be, the largest in the world is like 70 megawatts or so for an industrial site. Resiliency is critical, small enough to power laptop. And so, but the key is, in terms of sustainability, we still need innovations. And so, for example, the membrane typically is a perfluorosulfonic acid. So PFAS issues, how do we ensure responsible manufacturing? You have, the catalyst, again, depending on, the reverse is the electrolyzer, so platinum, iridium, and we're planning to launch a recovery recycling consortium with at least 50 million. So again, there's still a lot of, we have to get the cost down, need to meet durability, performance, but at the same time, looking at how do we design for the end of life so we kind of have that circular economy, I think is key.
So I'm just watching the clock. I hate to do that, but we have time for one more question I'd like to share with the panel. And I'm going to kind of merge two questions together, and then we'll open it up to the audience for your questions. And that is diversity. And diversity has many forms, right? So I want to see how, from your perspective, how is the federal government including diversity in technologies and other areas? And then I want to wrap up with a question. So Tony, you said you'd like to lead this question, diversity in the government?
I'm having a hard time actually hearing all. I hope the audience is not having this problem, but I am. What was the question again?
What?
You had difficulty.
What was the question again?
Oh, diversity is the question, and how is the government really addressing diversity in terms of the emerging technologies and directions?
Well, I think from my perspective, I think the government's doing a reasonable job. They have a lot of organizations. DARPA's been copied all over the place now, and with organizations like that, you have a tendency to really go out and searching for new things. Because if you don't search for new things, you don't have a job. So it really is a self-fulfilling prophecy. So I think I'm not worried about the government not looking at diversity. I think they're doing a good job. I really do, and I have no problem with that at all. I think it's well funded. I think people recognize that it's important to have research where you really don't know the outcome, because that's really what diversity is, and to allow that to happen. And so I think we're in good shape.
So as a panel, we have 2 more minutes because I'd like to then open it up for questions. But anybody else feel strongly about the diversity issue or forum that you'd like to add something?
Maybe if I could just say that I think the more we have very concrete programs, the better. So we have, for example, in hydrogen, we have an international partnership with over 23 countries. We launched an early career network, which now has over 40 countries. We have programs for HBCUs and kind of fellowships, the GEM fellowship. So I think, and our national labs also. So again, targeting specific, the emerging workforce, I think, is critical. Tribal communities and so forth. We just have a lot more we need to do, but I think it's off to a good start.
So I'm going to take out my crystal ball, and I'm going to say to Sean, we're looking into the future. So looking into the future it's 3 years from now. Which emerging technologies must the U.S. lead in to keep our competitive advantage?
I'm going to fight the question a little, but I'll answer it first. I think we must be a world player in AI and the cloud-based internet computing that is going to enable it to be a boon in so many aspects of our lives and our infrastructures. I think quantum will be gigantic, but I think it's a little further down than 3 years. And I think our interaction as a species with space is going to radically change things. But again, I think that's a little more than 3 years. But the way I'm going to fight the question is, and I served as a national security context, I think we have to admit that we will not be leading in every one of these technology areas in the future. When I look at current progress in quantum or in data sets for training AI, I'm looking to parts of Asia and China specifically who I might say are currently in the lead in some of these areas. So I think as the United States of America, one of our first things we have to realize is we will most likely not be leading in every area we might like to in 3 years, and to figure out where we need to for our integral national security, maybe onshore certain things, maybe spend more money in certain areas, but to be prepared for a default of some degree of globalization, whether it's in rare earth minerals or other technologies where we are going to be reliant on sometimes uncomfortable partnerships with other countries.
Tony?
Well, I'm concerned that if you look at progress has really been made by the computers, okay? And that the technology for the computers that now can be put into small packages allowing things to be done that could never be done before are all offshore the United States. In other words, the United States is not a leader in coming up with those new computers that are going to be able to put it into a very small space to solve very large problems. And so I am concerned that, well, the semiconductor, the greatest semiconductor is in Taiwan. You know, and that's a problem. If China ever does anything there, the world will be in trouble. And I think the United States is behind. I mean, it's behind in the diversity of the future, not that we don't have good capability. So I'm concerned about that. Because everything I know, remember, I'm an old guy, and I started 50 some odd years ago doing resource allocation and control where we had to go to the computer centers to get the things done. I mean, it's a different world today, and I can imagine, oh God, if we only knew that we could put the whole thing in this thing, you know, what we would have done 50 years ago. And so I'm worried about that.
So that's a thought to leave you with, not to worry, but I think it is a concern, and I'd like to see us be a leader in everything. So we'll see what happens as the future unfolds. But I'd like to invite audience members to come up. We have a few minutes left for questions. Please come up to the mic so we can hear you.
Hello, my name is Dipankar Dasgupta from University of Memphis. I have been in AI research since the last 30 years, and my first 15 years on AI in cybersecurity, and last 7-8 years on security of AI. So you all mentioned next 3 to 5 years how the AI will influence every sector. I'd like to hear from each of you, how do you see in your area AI will benefit or hurt the industry?
And AI with what?
AI technology, like in cybersecurity, there can be offensive, there can be defensive. In any other areas, you know, everything is cyber enabled, and AI is playing a big role in improving efficiency, whether it is a digital twin or chip manufacturing. So in 3 to 5 years, how do you see AI will take important place in a positive way? I'm just trying to understand any thoughts in that direction.
Who would like to start? Tony?
No.
Sean? Volunteer?
I think I've sort of given my view, but I'll happily share it. I think there are going to be quantitative efficiencies which will be capitalized. So there's so many things we do now that we're going to be able to do much better, much quicker, and at much greater scale. Think about the humanitarian crises we've averted through remote sensing from satellite platforms to be able to see agricultural or floodplain issues and help our condition. The flip side, I think you asked how it might hurt as well. I think we have to be prepared for a massive demographic shift in employment and training, because AI will supplant a lot of less sophisticated roles and even increasingly sophisticated roles in our workplace. So I think we're going to have demographic and societal changes, which we may be uncomfortable with, as AI replaces a lot of what many of us in this room probably do right now.
It's also going to create a lot of jobs, and
A
even
new
the World Economic Forum agrees with that one.
And
So-
but it'll be retraining and creating for new opportunities.
Okay.
First of all, thank you to the panel for the great remarks. Indeed, I have a question about digital twin. Indeed, digital twin is not a new concept. However, now we have new applications to address the emerging problems. Like due to climate change, we see more extreme weather more often. So for this digital twin can be used to do the better climate change mitigation and adaptation. However, to make the digital twin more powerful, data sharing is essential. Data sharing between different organizations, between states, between different nations. I want to ask, at the federal level, is there anything we can do to facilitate the data sharing? Thank you.
Who would like to take that?
To facilitate what? I didn't catch the.
Data sharing.
What?
Data sharing.
Data sharing. I think we do a good job of that now. I mean, I don't think anybody is. I think data sharing is you know, you have to go after it, but I think it's available. I don't think, you know, you're not going to be spoon-fed it. But I think data sharing is out there. I don't have any problems with data sharing. I really don't.
I think there are some opportunities, like we are reaching a lot more out to our allies. So, for instance, we are supporting a NATO Diana program, which is an accelerator. So this is really getting startups and early stage technologies working together and working in different nations and stuff. So there's those types of opportunities as well, which I think kind of leans in a little bit with the data sharing. So that's one way.
We're really out of time, but go ahead.
Okay, my name is Wei Chen. I'm from UT Arlington in Dallas area. I have a question regarding the diversity you were discussing, but I did not hear too much about the comments. I don't know how about in other states, other universities, but in Texas, like a few years ago, maybe hiring, we consider a lot of DEI. But now they say we don't need to consider the DEI anymore. So I want to hear more comments about the diversity. It is important or not?
You were talking about diversity in thought, diversity in education, diversity in what we're looking for.
Yeah, right.
Mm-hmm. Yeah, I think that's been a really key goal. So I know that the president has been pushing everything for more outreach to like HBCUs, looking for talent in unexpected places. That's one of the things the National Security Innovation Network was built for. We are the entry point. We are supposed to be out there looking for talent at the community colleges, at the universities, and really finding those problems and the solution, the people who can offer those solutions, and looking at it from that perspective for dual-use technologies and real-world problems. And I think that might address some of those questions.
And maybe I'll just mention, it is a really high priority, so I think the more we can share lessons learned. We also have the Justice 40 initiative for awareness, where 40% of specific federal investments would benefit, disadvantaged communities. So I think, diversity, DEIA is a huge priority.
Well, unfortunately, we're out of time, and I would like to have the audience please give a round of applause for our wonderful panel.